Good afternoon. It is very exciting to be here for after what, a year and a half that we didn't have like a physical meetup. So I'm happy to start this end of COVID in Israel and have this first physical meetup after like a year and a half. My name is Aviran. I'm VP Engineering for Wix. Today's talk is something that I personally am really excited about. We're going to talk a lot about things that don't exist, some visions like a moonshot vision, some things that actually do exist that we actually started to work on, and we're going to tell you all about it. So the topic of today is what's next? Okay, what comes after microservices and serverless, and what's the future of DevOps? Things that might change, maybe not. It's kind of a vision. So let's start. So for those of you who don't know what Wix is the leading website building platform. But many people know that Wix is more than just a website building platform, and this plays a role in this talk. What I'm showing on this screen is actually Wix Velo. Wix Velo is our development platform. So if you think about the website building platform, the website building editor, and think about it not as a website building tool, but as an IDE, okay, then you design your web page, your application page on the web, and now you can start writing code, both front end and back end and database and everything. So this is part of the Wix platform, and we'll get back to it later in the presentation. Some numbers. Wix has over 200 billion website builders that are building their website on top of our platform. Roughly between 5 to 10% of the websites on the internet running on Wix. Nobody knows exactly how many. We run in multiple data centers, and about 5,000 people work in Wix, roughly half of them in the R&D. Okay, so why are we here? We all work at companies, and we are engineers, and why are we working? Why companies hire us as engineers? Okay, it's the responsibility of the engineering, okay, to drive business value, to bring value to the business. We're creating the products, okay? But we want to work in successful companies, right? So successful companies, they deliver high quality code as fast as possible. Okay? The companies that actually win, that are very successful, can deliver code very, very fast. And for that, during the years, the decades that we have computer science and software engineers, the industry tried to change the way we work, methodologies, how we develop software, mostly around methodologies. So we had like the waterfall and the extreme programming, then Scrum and Agile and Lean, up to the latest buzzword is DevOps. Remember, DevOps is not a job description. It's a culture. It's a methodology. And the tools changed. The tools evolved and helped companies, even startups, to deliver software faster. Okay, so we got the cloud providers that abstracted the data centers and the physical machines and networking. We got our microservices methodologies, and they allow companies to scale up and maintain their software easily. And of course, the latest and greatest, serverless, which even takes more of the overhead of maintaining production. You don't really need to care about scaling, and you have less operational overhead. So the industry is moving forward, and we can discuss great success. Everything is great, and we can go home. Goodbye. So let's talk about what's building a service. So if you're just starting up, you're building a single service, it is very easy. Okay, you write whatever, you use any framework that you want, you write any code, anything that you want, you're free to go very, very quickly with all the tools that you can find on the internet and with providers. But we know in the real world, it's not that easy. We don't build just one service. So this one single service is actually connected and integrates with other services. It connects with services via RPC, it needs to connect to databases, it needs to connect to message brokers. It has all sorts of integrations. And now you started to create sort of dependencies that you need to test and that you need to operate and maintain and to discover. So you need to build some kind of frameworks around that. But still, this is a very small and simplistic application. And now you start to grow and your business succeeds. Remember, you develop code very fast, you bring lots of business value, and you get to something like this. And now you have a lot of microservices, and they all need to talk with each other. And when you have many, many microservices in your system and many teams working on them, now you need to think about, okay, what are the commonalities between them? I need to speak in the same language. I need to have the same protocols. And I need to take care of many, many concerns the same way, over and over and over. I need to handle cookies and security, and how do I do RPC call, and how do I log, and how do I A/B test, and monitor, and distributed tracing, and all those things that I need to worry about. And what do? We need to create some kind of common language, common framework around that. So after we have this thing, we get to the Starship Enterprise, or Battlestar Galactica. This is not actually Battlestar Galactica. This is Wix's production system. Every dot that you see is a cluster of microservices. Wix has over 2,000 of them running. I think it's more than that. And it becomes very complex to understand, to maintain. And how do you make changes to all those? All those things are, okay? It's complex. And it has a lot of overhead. So, how can we develop fast in a more complex and growing in complexity environment? So let's look and take one service, and how does it run, and how does it operate? Okay, so we have the VM that is probably provided for us by AWS or Google or whatever cloud, and we have the machines and the network, and it runs inside a container, right? And then you got the microservice, the application framework. This is your application framework. That for the JVM world, it's Spring. It can be Express if you're in your node, whatever. And then on top of that, what you usually build is you build your trusted environment framework. That's your contact. That's your application framework. What does it mean? It means every service needs to communicate in the same way, okay, via the same protocol, using the same header, having the same encryption, decryption algorithms and schemas, okay, and can use and be trusted by all the other services around that. So you're actually running on the same VPC network, on the same trusted environment where the outside world cannot come in, okay? But your services can communicate safely with each other. Okay? And on top of that, and put all the other concerns that you need to adhere to, like for instance, okay, if now everybody knows about GDPR, so every one of those 2,000 services has to deal with GDPR. Okay, you try to build that into the framework if you can. And once you finish with all that, then you write your business logic. Okay, and the organization, what it expects from us as engineers, this is what they need, the business logic. Okay, this is what we get paid to do. We need to drive business value. But it's a whole slew of things that we need to take care of before we can run our business code. Okay, so we need to discover, we need to connect to other services, with Kafka brokers, with monitoring and logging. A lot of things need to go into just one service with just this small business logic that it can be large, right? And of course, what you do with all those things, you need to test it, right? You need to test, you need to do the integration test, see if it connects to the database correctly, if you can send the RPC calls, if you send the message to your broker. It gives you, it puts a lot of burden and slows down the development process. So, what can we do about it? How can we increase our development velocity? I'll give you an example of you know, everybody likes to work in microservices, okay? And let's see one example of how that theme of microservices that doesn't fit everything, okay? So we have these services. We have accounting service, we got customer service, adverse, and now we have a business requirement, okay? We need to show, to have a screen, a new screen that shows the customer details and the customer balance, and at the end, we need the total for the business, okay? What are the business credit and income and expenses, okay? All in one screen. And now you have to do this, and you need to decide, where do I need to put this piece of code, okay? It doesn't really fit the customer service because it also talks about the business, the accounting, and I can't really put that in the accounting service because it doesn't really fit that domain. So where can I put it? It doesn't fit. So I say, okay, what's the problem? I'll create a new microservice. Just for that? It's a waste. You know, every service, now it needs to be in a cluster of at least 3. And if we're working in a multi-data center environment, then 3 times. In Wix cases, it's 4. Okay, and now you need to monitor it. And there's a cost associated with it. Okay, because you need now to provision 3 more VMs and run it. And just for this one function. So how can we solve this? Yay, Lambda to the rescue! Serverless solves all the problems, right? I'll put a Lambda function and everything will be great. But if you think about it, it's the same thing. You need to have 2 options, basically, with serverless. It's the same as a microservice. Either you put it, you want to run fast, you put it in an untrusted environment, which doesn't enjoy all your ecosystems and doesn't adhere to your contracts, which is a valid solution in some cases. Or I want to put it inside my trusted environment, and then I have to compile the framework, I have to adhere to all the contracts, and it doesn't really solve much. Okay? The only thing that it solves is auto-scaling. So it doesn't really solve my problem. So we need to develop and produce high-quality code fast. And let's imagine our perfect world, okay? We want easy development with minimal cognitive load. I don't want to operate a microservice just for one function. I would like to have minimal integration overhead. I want good performance, fast deployment, minimal testing. I don't want to, for every service that I have to do all those integration tests. I don't want to maintain a lot of services. Every microservice that I add to my production, someone has to maintain it, someone has to monitor it. It's an overhead. I want cheap scaling, run in multi-regions, and not a lot of boilerplate code. So what did we have so far? The best thing that we had, the easiest thing for developers that we had is a monolith. It's really easy to write. And for startups that I a lot of times consult startups and they ask me, Aviran, well, what should we do? Should we go to microservice? I mean, your startup, you have one service, write a monolith. That's the easiest thing. Don't start with microservices. Start with a monolith. But that's an easy. When you grow, you need to grow out of it. So you need to write it in a way that you can actually get out of it. But the monolith has, I mean, it's easily deployed, okay? You have minimal cognitive load. You don't need to do all the integrations and wiring and all the stuff. And it has great performance, everything runs in process. But it doesn't answer all the rest of our requirements. So we do microservices. But microservices, still, it only helps us with part of our concerns. It can deploy really fast, it's cheap scaling, but it has, as your system grows, that we see you have a lot of cognitive loads and cost and operationals. It's not the perfect solution. It is a solution, but it's not the perfect solution that we're looking for. And then, of course, we got the serverless, which helps us with fast deployment, with easy scaling, and it is a little bit ease down the operational overhead. So remember Velo? I'm not here to sell you Velo, don't worry. So when Wix developed our development platform, we tried to make it, our end customer was very junior people that need very little coding. So we tried to make the system as simple as possible. And in Velo, we actually deliver on all that promise, but it is very opinionated. Okay, it works the way it works. It works just with JavaScript, and you have just the functions that you need. It is very robust, but still, I mean, it's not something that a company at Wix cannot build Wix's ecosystem on top of Velo. It's great for building web applications, but it's not flexible and robust enough. It's not AWS, okay? But it solves a lot of the concerns. So we looked at it and we said, how can we take all those concerns that we build inside our own product and bring it to our own engineers? Why shouldn't our engineers enjoy the same values, the same ease of development that our customers have, but with greater flexibility, with basically almost no limits? But you have to be a professional. It's not for novice. So what we try to do is we try to take the best from every world, from microservices, from serverless, from monoliths, from managed platform, and we try to envision, and I reiterate, some of the things that I'm talking about is a vision. It's a moonshot vision. It's very far away in the future. Some of the things we're already doing right now, and this is the way that we believe is the way to go. So what we're talking about is a platform as a runtime. Okay, and we're gonna talk what does it mean, a platform as a runtime. So with Wix platform as a runtime, we actually started with serverless. So you ask, why would Wix need to build its own serverless platform? Because of the trusted, untrusted thing. and because of all the boilerplate overhead that we want to solve for our developers. So how does it work? It works on the lowest level, it runs on Node. It runs Node.js. And on top of that, what we build is we build the application framework. And it is part of the runtime. You don't need to compile the framework, the Spring, the application framework in your code. It's provided to you in the platform, in the runtime. When you deploy your code, it's already provided. So the application framework runs as part of the runtime, of the serverless runtime. On top of that, we added the service integration layer. So when you need to connect to call another service, you don't need to do all the lookup, the discovery. You don't need the integration test. It's already integrated. All you have to do is ask, I want to connect to this, and that's it. It's connected because it's part of the runtime. And on top of that, we build the data services. Okay, so if you want to go into database, you just ask, okay, give me a database. You get the database and write. You don't need to handle with connection strings, with JDBC, with connection pools. It's all provided to you via this runtime environment that your code is actually part of. And now all you have to do is write your business logic. Okay, you don't need to compile it. You just write the minimum amount of code of your business logic. So why did we choose Node? Node is very lightweight. It's dynamic code loading, and it's very easy for developers to learn. So this is why we chose Node.js. The application framework is based on Express. And it handles, like I said, all the trusted environment contracts. The HTTP header, authorization, logging, monitoring, everything is inside the application framework, runs a part of this runtime. The service integration is basically a repository of all Wix's gRPC and REST clients. It's protobuf based. And of course, the Kafka client integration is also there. So you don't need to bring that with your code. And the data services, we have basically two. You got a key value store that you can call, and you can interact with Wix as a data layer. So how does it work? This is your code. Okay, you write your code, your minimal amount of code, and the serverless environment, the platform, it's already running in the cloud in Wix's data center. And once you finish, you want to deploy your code, you don't build Node, you don't put Node.js or container that you put a container and deploy. You just deploy your JavaScript file. Okay, and the JavaScript file just goes and linked, dynamically loaded into the platform. And of course, and this is something that we built that you said, okay, so far maybe it's close to Lambda. Okay, resemble. But what happens when you want to add another function? With AWS Lambda or functions for Google, you have another instance of this. Okay, because that's an untrusted environment. So you basically need to wrap everything, every piece of business logic, every piece of framework that you have, and run that in another containerized application. But since Wix is running with its own trusted environment, what we can do, and this is something that we're actually doing, we can run all these functions inside the same process, okay? And we achieve a huge cost effectiveness because this is just one instance of a service that runs multiple functions. And the reason we can do that because they're trusted. They are developed by our own engineers. It's not a third-party code that I don't trust. I trust him, and I trust her, and I trust her. I trust the people that build this code. This is why I allow myself to run them in the same container. They can call each other. I don't need to do all the security. I don't need network boundaries. I don't need anything. It just runs in process. So what we achieved in this scenario. So we achieved that we don't need integrations. Okay? So we don't have, I just need to declare whatever I want and I get it from the platform. Okay? I don't need to do a lot of testing because most of the integrations are already in the runtime. I don't need to test my environment. The same thing if an example is, if I'm running on Windows, I don't need to test the file open API. I know it works. Okay? So I don't need to test the platform. And I can think in very, very small functions, just your business logic. And I do a very quick deployment because my deployment is very small. I don't need to compile and build and wrap all the frameworks, all the Node and Docker and everything. So it's a heavy deployment, heavy package. I just need to take my small JavaScript file and upload it to the server. Okay? And I have zero boilerplate. All the integrations are already provided to me. So let's see a real example. And when I show this, think about what would you have to do if you scratch from nothing, if you start from nothing. And we're going to do a small thing that we want to add an API to retrieve a task detail from the task microservice, add the person's details who is assigned to this task from the contacts microservice. Okay, this is our code that we need to write. And another thing that we need to do is to create to listen to a Kafka event that writes an audit log every time a task was created. Okay, so this is what we need to do. Think about it. How many lines of code would you have to write in order to do this thing from scratch, not add it to an existing microservice? Okay, you want to do a containerized function or a task. So this is what I'm showing you is the actual code that will be written and will be deployed. Nothing more, nothing less. Okay? So what I need to do is to declare the services that I want to connect to. Okay? So in this case, we have this task server and the contact server. So I just declare this is what I want. I create a function. Okay, so I can call it from the browser. I declare the function, and that's it. And I call the services. I call the task server to get the tasks. I call the contact server to get the contact. And I return the data. Okay? That's it for now. This is for bullet number 1. Now I want to add a Kafka listener. So I add a Kafka listener. Add Kafka, I get the Kafka consumer, and I write it to a database. I get the database, I get the data store, and I write it to a table. And that's it. I don't need to handle build files. I don't need to handle anything. This is the code. All I take is this code and press a button, and that's it. This is all the code that... Yes. So this is all the code that I have to write in order for this function to work. So I click push. It's actually taking the code from GitHub. Once I click push, it takes the code, and in 10 seconds, literally 10 seconds, it's running on production.
Yeah, test.
What?
Where's the test?
There is no test. You can write a test.
Okay. No test is okay.
I don't write bugs. Okay, so push, build, deploy, and run in less than 10 seconds. So it's a minimal amount of code. I didn't compile any framework into my code. I have no boilerplate. The deployable artifact is very, very small. Okay, so I can deploy it very, very fast. And another added benefit of this system is I actually separate the source structure from my deployment packaging. if you think about it, the way that we develop microservices, okay, we think about the domain, so it's the same structure tree that I have in my IDE. It's basically, this is what is going to production, okay? And this is the deployment unit, this is the deployment, the runtime, all the code that I see here. In this case, this function will run with other functions. It doesn't really matter. I don't need to think about how I package it in order for it to run. Okay, just okay, this is the function I can run. I could just as easily separate it into two files, one for the Kafka and one for the get method, and it would run the same. So this is the basis of our platform as a runtime. Okay, it's flexible, dynamic, it's optimized, it's very cost efficient, okay, and it's scalable. And I can just, what I need to scale it, I just need to add more instances of the runtime and deploy the functions in any way I want. Now, from here on, I'm going to talk about a little bit about our vision to the future. Some of it will be far future, some of it is already in the works. Now, think about the things that we can do with it. So, this is one strategy. This is actually something that we do have, is I want to give responsibility for different teams to still monitor and be responsible for their own systems, okay? So it's very easy because what I have to do is create this runtime environment for the ecom group, I create another runtime environment for the payment group, and they can deploy their functions any way they want, and they can still be responsible for their own code. Okay, I don't mix code from different teams to different runtimes. Okay, so I can virtually create the microservices with the same responsibility of teams that they can operate their own runtimes. Now, as you saw, maybe you remember, as you saw in the code, that you can see it, calling an RPC call is just calling a function. Okay, so it doesn't really matter if I'm calling in process or I'm calling out of process. Now, what that allows us to do is basically do an auto-scale. If you think about scaling in a microservice world, what I'm scaling a whole microservice. Here, I can actually scale a function. Okay, this can be a microservice, consists of those three functions, and this can be a microservice, consists of these three functions. But only this method, like not all methods are the same, right? Some get more traffic, some get less traffic. But now I can only scale this one. If this gets a lot of traffic, I can scale function 4 and just deploy it to another runtime, and everything is taken care of for me. Okay, it doesn't, like I said, doesn't matter if you call it in process or out of process. I can just auto-scale on a function level. So this is one advantage that we have in this model. Now, another thing, and this is a vision, we don't have that. We don't have this, but this is, I really hope that we will at some point. Think about the optimizations that we can do it. We can optimize the function's affinity based on the runtime. So what do I mean? Okay, so we got this runtime and that runtime, and we can see that function 2 and function 5 frequently interact. Okay, so what can I do about it? I can add function 5 here. I can add function 2 here. And now they call each other in process. So I optimize the runtime to not have a network call. Okay, so I get a performance boost optimization, basically similar to what a JIT compiler does. It looks at hot pieces of code and optimize them as you run. And in this case, I do it on the platform level on the runtime. So I see which RPC endpoints are frequently called. And if the platform understands by collecting statistics and stuff, the platform understands that these interact a lot, this is like a hot spot of network calls, it can just say, okay, deploy it in the same process, and I eliminate the network calls. And I get performance, I get resilience, I get a lot of benefits. Yes?
When you're speaking here about nodes, you are taking multiple functions and integrated them to a single Lambda?
Yes, in the same node process. Yes. Dynamically load into the same node process.
You're not actually using serverless, you're using containers that are running, like serverless is Wix.
It's Wix serverless, yes, it's our own platform.
It's not Lambda.
No. We stopped talking about Lambda like 10 slides ago. Okay? We're talking about what Wix is built, okay? This is what we built. This is why we're not using Lambda, because you can't get that in Lambda. So this is what we have, okay? Or this, in this case, we don't have that yet. It's in the roadmap. This hot JIT performance compiler, whatever. Okay? So this was a taste about the benefits that we can get from it. We also built into the platform the data services. Okay? So we built a key value store, as you saw in the example before, just to use a database. I don't need a connection pool. I don't need JDBC. I just request, okay, give me data store and put the data in there. Everything is integrated. Everything is already there. I have managed the Wix data, which is basically the underlying Velo, and other data services that I can connect via APIs. And of course, in the very, hopefully, short future, we'll have also the MySQL integrated into the managed MySQL. So we achieved a lot just with this pattern, okay? So we have no integrations. We have less testing. We don't need to test all those things. We think in very small functions. We got auto-scaling. We got the platform runtime optimizations. Of course, the multi-region I didn't show, but it's also multi-region. And then the data services, of course, it's managed. So I don't need to manage all the databases that I have. I have zero boilerplate. You see, just the code that I needed to make my business logic work. Okay? The thing, it's opinionated. This is the way we work. And it's good for 80 to 90% of use cases. It will be good. So this is how our very high level, this is how our environment is looking. Okay, so we got the API gateway, and we got the microservices running alongside with the serverless functions. If you got a very specific domain and it's good, it doesn't replace as microservices. It's an addition. Some things fit better here, some things fit better there. So they run together, and everything have access to the same layers of the data layers. So our end goal is with this platform, with the serverless platform, is to solve basically, hopefully, 50%, at least 50% of use cases that we could leverage that. So far, we don't have all the features that I show, but we do have hundreds of functions already running in production. So far, the best use cases that we've been using, for various reasons, mostly because we're still missing the database. We have the key value store, but we don't have a MySQL part there yet. So a lot of the front-end use cases, front-end servers use cases fit very well into that pattern, because it's something very specific. It doesn't fit into an existing microservice. I want to write very fast code. So we got hundreds of days. Also messaging, listening to a Kafka, put it and send another Kafka, do a webhook, some sort of processing. These use cases fit very good in these scenarios. Once we'll have the database layer, the MySQL database, the relational database, which currently we have only the key value data store. I'm guessing that a lot of more use cases will fit into the serverless platform. So we achieved that we brought business logic very, very fast. Okay, our developers that are using it, they're loving it. And they say they're able to develop things that in the past they used to take like days and weeks, and now they can do them in hours. So now we have that we had that, and we have a lot of some experience. This is running in Wix for what, 2 years now? Something like that? More, yes. We think we can do better. So this is a work in progress. This is a vision. This is something that we're actually actively working on. Why just JavaScript? Why not additional languages? The problem with multiple frameworks, this is something that I always say when some people ask me about microservices. Should we be a polyglottic system, write in any language? And I say, definitely not. Okay, because there is a lot of, you saw all the contracts, all the overhead that you have around, you'll need to develop in all the languages that you support. But if we change the paradigm that we don't compile all the framework into each and every technology stack that we use, we can actually support more languages a lot easier. So this is something that we started to learn. Wix single runtime. And let's go back to the pyramid. Okay, so what we're trying to build is take the common concerns and take them out. Okay, and so we have the single runtime framework. Okay, we got the service integration just as before. We got the data services. And we separated that to, this is the serverless container. It's now not part of the, up until now it was part of the runtime. So this is actually the platform. This is built on top of the platform, the serverless, the ability to dynamic load code and auto-scale on the function level, et cetera, et cetera. So we separate that. So, and once we separate that, we can actually develop the application framework only once. Okay, because up until now, the application framework set inside the implementation, the Node.js is implementation detail of that platform. Okay, so by taking it out, we can develop the application framework and all the concerns and all the platform separately from the runtime. And this is what it will look like at the end. Okay, so we will have the single runtime, which has all the integrations, all the framework, all the common concerns, all the contracts. And on top of that, we can have the serverless environment, and we can have the microservices, a polyglottic system, because we don't need to develop the framework for every language. It already exists. It will get injected or provided to you with any language that will add. And of course, the data services that everything will be connected to. Here we'll need probably some kind of small adapters for language support, maybe some kind of library, but it's not the full-blown infrastructure. Another big advantage that will have that is updates to the framework. Okay, how do you update if you have an environment with thousands of microservices? Every time you do a framework update, now you need to deploy everything, okay? And you need to wait. It takes time. So you get multiple versions of the framework, and you need to wait for everything to be deployed. So basically, at Wix, we never have a single version of the framework because it keeps updating. And by the time everything is deployed, 10 new versions already being released. But in this case, since this is the runtime, okay, we can quickly deploy a new framework, and at once everybody will get the new framework. Okay, so this is another one. It has other challenges, like how do you updating this without bringing the whole system down, but this is another issue that we're not going to talk about right now. And I think that's it.